Welcome back, guys. So from today we are going to start another series which will be related to the solution of the exercise problems of the book Discrete-Time Signal Processing by Oppenheim. Okay, so we have been starting it from today, and this is question 2.1 of chapter 2. So the statement of this question is, for each of the following systems, determine whether the system is 1 stable, 2 causal, 3 linear, 4 time invariant, and 5 memoryless. Okay, and these are all the options for these questions. Okay, these are all the systems, and we have to find out that whether the system fulfill the criteria to be stable, causal, linear, time invariant, and memoryless. Okay, so before proceeding to solve these parts, let us first find out that what is meant by each of the terms here. Okay, so the first term here is the stability. So what is meant by stable? The first term here is stable. Okay, so what is meant by stable? So suppose we have a system. Let me first represent a system here. This is a system. Okay, we will also represent our system by this, and it will be given when some input, it will create some output. Okay, so if it is given x of n, it will give y of n. So it will be stable if the input is bounded and the output is bounded as well. Okay, so what is meant by bounded input? Bounded input means x of n approaches 0 when time approaches infinity. Okay, similarly for it, the output y of n will also approach 0 when time will approach infinity. Means this will be a system like this one, that it will decay with time, and the output will also decay with time as well. Okay, so this is what this will be, a system which has the values x of n less than or equal to some value m. So the output for it will also be less than or equal to some other value n. Okay, and it is bounded, means it is under control. So stable means under control, and mathematically we can write them like this and this as well. Okay, so this is the definition of the stability. Now the second term here is the causal. Okay, so let me write it here as well. So causal, what is meant by causal? Causal means the output of a system will only depend upon the output, which is y of n. It will only depend upon the present and past values. Okay, and it doesn't depend upon the future values. Future values mean the events which haven't been occurred yet, but the output has occurred. This type of the system where the future values are encountered, those are the non-causal systems, and the present values of the inputs are x of n, the past values are x n minus 1, these are the past value, while the future values are x of n plus 1 or so on. Okay, so these are all the values which are, if a system is causal, it will only depend upon the values which are present and past. So the example of those type of questions are here. So if this says y of n, the output is x of n minus 1 plus x of n minus 3 plus x of n. So all the values here, you can see that this is the past value, this is the past value, this is the present value. So all of them are basically are adding together and give me the output. Similarly, if we have y of n equal to x of n plus 5, x of n minus 5, and x of n plus 10. So here you can see that this is the present value, this is the past value, while this one is the future value. So this future value is basically adding with all other values and giving me the output. So this is what, this is the non-causal system, while this one is the causal system. Okay, so before proceeding to solve the question, we must know that what is meant by these terminologies. Okay, so the third one here is the linearity or the linear systems. So this is a linear system. So what is meant by linearity? So again, let us have a system to which an input has been given. So suppose we have given two inputs to two systems. So this is x1, okay, and this is x2, okay, and these are the systems we have, and from here we are getting the outputs. Okay, so this is x1, the output of it will be y1, this is x2, the output of it will be y2. Okay, suppose we have been doing what, let me add another thing here, and that is the multiplier. Okay, this is the multiplier, and here to this system we have been multiplying a term, let me call it a, and with it I have been multiplying another term which is called b. Okay, so the output here would become what, it would become ay1 and by2. So after it, these will be added together, okay, and the output of it will be what, the output of it will be ay1 plus ay2. Okay, so the inputs are given and these are the outputs. Similarly, the similar approaches are here, that we have two inputs x1, x2, these are given to two systems where have a and b, where we have here a and b. Okay, these are given to us, and here we have got ax1 and here we have got ax2. Okay, so after it, these will be added together, this is the scenario, and here after adding them, what will we get, we will get ax1 plus bx2. Okay, so after it, these are given to the system which is the similar one which we had here. Okay, these are the similar type of systems. Okay, and here the output of it would be what, the output when we have obtained it would be ay1 plus by2. Okay, or this is, let me call it, let me have here this capital A and this capital B, and the system will be linear if and only if A is equal to B, and this is basically because of these terminologies. And if we simplify it some more, how it would be, it is saying to us that ax1 plus bx2, when these are given to another system which is with us, these are the systems, when these are given to this system, it will be ax1 plus bx2. So ultimately it should give us what, it should be tx1 plus b tx2, and it will be ay1 plus by2, because of what, because here we can see that this is the system processing and it has given us this one and it has given us this one. So this is the definition of a linear system if it satisfies the superposition theorem. Okay, we have to apply these statements here, or we have to apply this formula. If it satisfies it, it means the system is linear. Okay, so that is about the linearity of a system. Fourth one here is the time invariant. So what is meant by the time invariant system. So let me first make a diagram for it. So if this is a system and the input which has been applied to it is x of n, it is applied to this system, and here we have got this y of n. After we have got it, we will give it to another system which is of a delay system, and it is providing us the delay with some instance n naught, and the output of it will be y of n minus n naught. Okay, so all the terms here with n will be given some delay. Similarly, if we have the similar signal x of n, it is first delayed with n naught, so the output of it would be x of n minus n naught. Okay, when it is given to the system after it. Okay, so this is a system. When it is given to a system, the output of it should also be y of n minus n naught. Okay, if these two are the similar one, the system will be time invariant. Okay, means it doesn't depend whether you apply the delay initially or at the end, but all the variants of n will be delayed accordingly. If it doesn't satisfy this condition, this would be the time variant system. Okay, so this is about the time invariant system. The last one here is the memoryless system. Memoryless system. What is meant by the memoryless system? So if a system has the memory, it means that y of n will be the summation of some values which are x of n minus k, where k's will be from 0 to infinity or from minus infinity to infinity, means all of these values will be what will be stored. If x of n minus n naught is giving me the output y of n minus n naught, or x of n naught is giving me the output at the similar instant n naught, the system is memoryless, means it doesn't store any instant or any sample to give us the output. Okay, so that is about the memoryless system. So that's it for today, in which we have discussed stability, causality, linearity, time invariance, time variance, and memoryless systems or memory oriented systems. So in our next video, we will try to solve the parts of our question. If you have any query regarding the contents of today's video, you can ask me in the comment box. See you soon.